Hello everybody and welcome to Brady's Lab, and in this video we're going to be taking a look at my homemade Geiger counter. You can see it sitting here right now ticking away, and if we bring a radium watch near it, it goes pretty crazy. But before we get into testing this device with some other radioactive sources, let's take a look at how it works and how you can build one yourself. Okay, now let's take a look at the schematics for the Geiger counter. So here you can see the high voltage comes in from the high voltage generator, and we'll take a look at that circuit in a sec. But then the output of the high voltage generator goes to a 4.7 mega ohm resistor. Then it goes into our SBM20 Geiger tube, which then goes into the base of the BC517 Darlington NPN transistor. The reason I used a Darlington transistor is the circuit wouldn't work with an NPN transistor. I'm guessing the current from the high voltage power supply just wasn't enough to trigger it. But if you do build this circuit, I would try it with an NPN transistor first, just due to the fact that Darlingtons are very, very sensitive to interference. Then we have the speaker, a 8 ohm mini speaker, that goes to the 9 volts out of the battery, which then the negative of the speaker goes to the collector of the transistor, and then the emitter goes to ground. So let's go ahead and take a look at the high voltage generator circuit. Okay, now let's take a look at the high voltage power supply section. But before we do, I just need to say this is from techlib.com and I did not create this. The link will be in the description to where I found this. So up here is our 9 volt battery input, or you could use a power supply. And then here is our high voltage output. And then right here you'll see these Zener diodes, and these are very important because these configure the voltage. And so in this case it has two 120 volt Zener diodes, and this makes 500 volts. But in my case I changed these to two 100 volt Zeners, and then I got 435 volts on the output. And so you can change these to get, for exactly 400 volts, or lower or higher depending on what kind of Geiger tube you're running. I think the upper limit of this is around 700 to 800 volts, so pretty high. But yeah, let's go ahead and test the Geiger counter with some radioactive sources. Okay, now let's test the Geiger counter with some radioactive sources. So our first source here, going from lowest to highest activity, is this, a piece of trinitite. This is glass that was formed in the first atomic bomb test due to the intense heat in the surrounding desert. I'd say there's a reaction. Next is this, a uranium glass candlestick. What this is glass that just has a small amount of uranium added to it to give it this nice green color. And it's not very radioactive. Next is this, a uranium glass plate, and it's much more active than the candlestick. And so there's a pretty good reaction. Next is this, a ivory Fiesta ware plate, and this just has a small amount of uranium added to it. Next is the radium watch, which of course you've already seen, and it gives a very good reaction. Next is my hottest source. And as I approach with it, you can hear the Geiger counter already starting to react. So what this is a uranium glazed ceramic piece, but instead of being ivory, it's orange. And they added much more uranium to get this color. So, as you can hear, it's not very happy. So yeah, if you want to build this Geiger counter yourself, then just remember the high voltages. It probably won't shock you, but you can never be too safe. And then of course, when it comes time to test it, you're going to need radioactive sources. Now all mine are antiques, which are pretty safe. But once you start getting into uranium ore and stuff that can flake off, then you're going to need to follow some safety precautions. But anyways, thanks for watching, and I'll see you next time.